All right, we are on day 2 of 12.2. And we are today focusing on the probability of dependent events or combined probability. Okay, so 2 dependent events together. I wanted to point something out that we talked about on day 1. So here's my answer key to day 1. And on day 1, I had this formula. It says the probability of B given A is equal to the probability of B and A divided by probability of A. So in this formula right here, this formula very much relates to this formula. And here's why. So look at my 2 fingers. On my bottom formula, if I want to isolate my P probability, the numerator, probability of B and A, which also I could write the probability of A and B. You can switch the lettering. Say, what's the probability of A and B happening? What's the probability of B and A happening? That just means that they're happening, like both of them. Well, in the denominator here, if I want to solve for the numerator, I would multiply, clear the denominator, multiply by the probability of A on both sides. So you can see I did it. And this right here, probability of A times probability of B given A, is this right here. Probability of A times the probability of B given A. So this formula, just altering it a little bit, solving for the numerator, gives me this formula that we're talking about today. So this is all related. It's one and the same. Just manipulating the formula. So I want to just draw that connection first off. And then I also wanted to explain. Okay. So this is a conditional probability. We're still doing conditional probability. Let me move my chair over. Sorry. All right, let's check out what we've got on number 1. A band's marketing agent conducted a survey to determine how many high school fans the band has. So what is the probability that a surveyed student that plans to attend, a student that's going to attend a band's concert, is a fan of the group? I'm going to call the fan of the group the B. So this chart over here is important. All right, 70% of the students plan to attend the concert. So this band is having a concert. 70% of high school students plan to go. And if 70% are going, look at 30% aren't going. That's my complement that I did way back on day 1. 1 minus, what is it? What's not attending? The not. So it's 1 minus 70% equals my 30% that are not going. And I think my camera's blocking it. Let's go over there. So 70% of the students are going. Of those students that are going, 80% are fans of the band. That's a lot. 70% of the kids are going, and then most of the kids, pretty much all the kids, are fans. They know their music, they follow them. And then the students who do not plan to attend, obviously this is the 1 minus 70. Only 25% are fans. So not many students, like there's not a, okay, the kids that aren't going, they're not really fans. So it's fine, okay? Only a quarter of them are fans. So these numbers are low for the kids that are not going. These numbers are high for the students that are going. So here's what I'm going to do. I'm going to incorporate this formula, the probability, and I want to point out, I can use another symbol, this intersection. It means and. It's an upside down U. And I'm pretty sure you guys use it in science. This is, I'm going to do my formula. The probability of A happening, probability of students that are going, times the probability of B given A. which is of the people attending, of the students attending who are fans. That's what this B given A is. The students that are attending, A, who's a fan, B. Remember how the first thing, this is my prior event. A is my prior event. First, I have kids going to a concert. Then look at the variable in front, who's a fan. So let's go back to my little chart. I'm going to plug in values for this probability of A times probability of B given A. Probability of A, the probability of a student going, A. Sorry that there's this giant B in front. That means the fan of the group, right? I don't want you to think that that's, I'll put a B over my sentence. These aren't related. This is from before. The students going, that's 70%, 0.70 times, do an X so you don't get your decimals and your multiplication confused. Of the students attending who are fans, of the students attending, 80% are fans. That's this right here, 0.80. So I multiply those two. I have the roster. I'm happy to call on people's names but I need volunteers today. So volunteer.
0.56.
0.56, you're right. So 56%, the students who plan to attend and they're a fan of the group. This is a student going, attending, who also is a fan, 56%. Probability 0.56. If you want it in percentage form, 56%. Part B, what is the probability that a surveyed student plans to attend but is not a fan of the group? Okay, well, you guys, if I am going to attend, that's my 70%, that's my A, but not a fan of the group, this is the complement. How many students are not fans of the group? Because the people that are going, 80% are fans of the group. Who's not going? If 80% are fans, who's percent not fans? The students that are going but not the fans. 80% are fans. So how do I find out who's not a fan?
It'd be 20%.
Right, and I got that from subtracting. This 0.20 is, these are fans. They're attending the concert, but they're not fans. That's 20%. So here it is. Let's say C is not a fan, because we already did B. We already used B for something else. So the probability of A and C, I could also use this symbol, equals probability of A times probability of C given A. Probability of A is the kids that are going. How many kids are going? 70% are going. Then this one, they're attending, but they're not a fan. Who's that? They're attending, but they're not a fan. What value?
0.20.
0.20. Thank you for volunteering. When you multiply those out on your calculator, quick. Okay. Questions on example 1? let's go to example 2.
Wait, so you got the 20 from subtracting 80 from 1.
Yeah, because 80% is the people that are fans. The people that are going that are fans, that's 80% of the people. So that means that there's 20% of the people sitting there at that concert that aren't really fans. And that's 100% minus 80%. 20% aren't really fans, but they're going to go to the concert anyways. Example 2. A marketer, so marketing is a person who looks at how can they sell their products better. A marketer is looking at mobile phone statistics to help plan an online advertising campaign. So it's online and they want people to use their mobile phones to purchase. So you buy something on your phone, like online, like a Google search or Amazon or something. She wants to find which product is most likely to be purchased after a related search. So when I search for a miter saw, what's the chance that I'm going to buy the miter saw using my cell phone from the company's website? Okay. So find the probability a mobile phone customer buys given that they performed the search. This formula is probability of searching and buying divided by the searching. Okay, so here's my chart, which looks great, by the way. I've got searching and buying is my column here. And this is just searching. So I'm going to use these percentages for finding product W, X, Y, and Z. This is way easier than you think, you guys. So what's the probability? My numerator is the probability that I'm going to buy given that I search. Obviously, you can't buy it unless you search it, right? So I'm going to do, this is the fraction. Search and buy. Product W is 16% divided by the probability that I search, which is here, this middle column, 0.46. So grab your calculator and you're just dividing 16 hundredths divided by 46 hundredths. And I'm assuming you got what I got, 0.348. So I'm looking at this chart and I'm just writing down data from this chart. X, searching and buying, 0.14 divided by 0.32. See how easy this is? Do the division. .438. You guys all have your calculators handy, yeah? So again, I mean, I can write it each time, but it's just redundant, but I can. So I first have to search it and then I buy it. Y, product Y. Search and buy, 12%. First did the search, 35%. This is a little lower. What's this decimal? Someone tell me. This one, someone tell me.
0.342.
Yep. Last one, do it on your own. Z. Here's my data. Bottom row. Go for it. Someone tell me the answer after you get it.
0.375.
0.375, perfect. So which one has the higher buying rate after my initial search? After a customer searches for it, which product has the best chance of being purchased?
X.
X. Because it has the highest percentage. Good. We're doing the same thing for next. Example 3. Now the marketer also has data from desktop computers. Which product is most likely to be purchased after a related search? So it's J, K, L, M. So it's my percentages. I'm going to do search and buy divided by search. Same thing up here. J, 0.10 hundredths divided by 35 hundredths. 0.286. K, L, and M are all the same. Just go through, write them without my help. You're just dividing. Get your calculators, have it all ready to go. All right, I need different volunteers to give me their decimals. For K, what'd you get?
0.321.
Great. For L, what'd you get?
0.307.
Good, good. For M, what'd you get?
0.21.
Sure. I know that you got 208, but it's the same. So look at the data, which has the highest buying rate after the initial search. Highest percentage, 21%, 30%, 32%, 28%.
Okay.
Okay. Good. So our homework tonight is a few problems. It's on all of 12.2. So let me first stop the recording.